Hi, today we are looking at one of the most useful visual features of the P5, the mimic display. If you have ever looked at the relay screen and seen a digital diagram, you see circuit breaker and bus bars. You are looking at the mimics. It is essential in the single line diagram that provides a real-time animated snapshot of your electrical bay. The mimic isn't just a static picture, its primary job is to show you the status of your equipment at a glance. Because it's animated, you can see whether your circuit breaker is open, closed, or in an undefined position. It can monitor your control up to 6 objects, such as circuit breakers, isolators, and earth switches. Besides the diagrams itself, the mimic can display up to 8 freely selectable measurements. This means you can use your phase currents like L1, L2, and 3, or line voltage directly on your same screen as your breaker status. You can also choose to show the status of auto reclosing or specific virtual inputs. One of the coolest features is local control. By navigating the cursor over the object on the mimic using arrow keys, you can press OK button to bring up the menu. From there, you can issue an open or close command directly from the local panel, provided you have correct passwords and access rights. You don't build this on the relay itself, you design your custom single line diagram in the eSetup software. You can draw lines, add text, and drag and drop predefined symbols for your motors, transformers, and switches. Once you're done, you upload it to the P5 and it becomes your default operating screen. Think of the mimic like the GPS map on your car dashboard. You could drive just by looking at the road coordinates and speed numbers, but the map shows you exactly where you are, which turns are available, and whether the road is open or closed. The mimic gives you the same navigation clarity for your electrical switchgear. The stand features 3 primary switching devices that you must master. Firstly, circuit breaker, VL or 1Q0, the only device designed to interrupt fault currents. Next we have the disconnected or isolator, LL or 1Q1, which provides a visible safety gap for maintenance. Finally, there is the earthing switch ML or 1Q8, which safely connects the circuit to the ground bar to protect personnel. In your secondary schemes, these are monitored via digital inputs in slot B and slot C on the relay. To make the relay see the network, we configure the scaling settings. In the stand, we use the P5F30 model. You will set the VT primary to match your network, for example 11 kilovolts, and the VT secondary to standard 110 volts. For F volts, we use VN secondary, typically set to 10 volts, which allows your relay to measure neutral displacement accuracy. Remember, the voltage measurement mode is usually 3LN plus U0, allowing the relay to measure residual voltage directly from the broken delta. The relay is programmed so you cannot close the earth switch 1Q8 while the circuit breaker 1Q0 is closed. We also define the phase rotation, usually 1 to 3 or ABC, which is mandatory for the electrical protection function like ANSI 67 and 67N to work correctly. First, let's break down the terminology. K01, it refers to compartment 1 or bay 1 of the training system. This is the earth switch, the device that connects the circuit to the ground for safety during the maintenance. 1Q8, this is unique object ID. It stands electrical schemes Q8 designed and earthing switch, and the 1 tells it to belong to bay 1. Alias, this means off or open. It tells us the switch is physically disconnected from the earth bar. So how does the Easergy P5 know the switch is open? It's all about the digital inputs in the stand configuration or bay Q01. The off status of the earthing switch wirely directly to the card C, digital input 5. Especially the auxiliary contacts on the switch 1Q8 are connected to the terminals C5 and C6. When that circuit is closed, the relay receives a signal confirmation. The relay communicates this to the U in 2 ways. Physically, you see indicator H1Q8 on the panel. According to our project legend, a green light means that switch is off, while red would means it's on. Digital, this is reflecting on your mimic display. The F switch symbol on the single line diagram will be shown as open contact, providing a real-time snapshot of the bay state. This isn't just for show, the signal is a vital part of the object block matrix. The P5 is programmed with the safety interlocking. For example, you cannot close the circuit breaker on Q0 if the earth switch is still on. This relay requires that off status of the unlock. The rest of your switching operation prevents a catastrophic short circuit ground. So when you see K01 maanduslüiti 1Q8 väljas, you know bay 1 is not longer grounded and it's potentially ready for service. Always verify your physical switch position against the HMI before proceedings. Think of the status like the safety off light on a piece of heavy machinery. It is the relay confirming that the safety pins, the ground connections have been removed and the system is now underlocked and ready for the next phase of the operation. If that light isn't on, the computer and relay will simply refuse to let you start the engine. K01 maanduslüiti 1Q8 says, we previously looked at the open status of the switch. Now we're looking at the opposite and most critical safety state. You might see the signal K01 maanduslüiti says on your control interface. This translates to bay 01 earthing switch 1Q8 is closed or on. Let's dive into hardware and logic that makes this happen. K01, as we know, this is component of the bay 1 of the RPU stand. This is earthing switch. 1Q8, this is the specific identifier for the earthing switch on the bay. Says this means on or closed. In this state, the primary circuit is physically bonded to the earth bar for maintenance and safety. The P5 relay monitors the closed state using the dedicated digital channels, looking at the secondary schemes for the bay 1. Bay K01, the says status is wired to the card C, digital input 6. This signal enters the relay through the terminals C11 and C12. This is the physical switch 1Q8 is fully closed. This auxiliary contacts terminals 13 and 14 complete this circuit, telling the relay that the system is safety grounded. How do we verify this status? Firstly, look at the physical panel. Indicator H1Q8 will turn red, which indicates that the closed position is on. At the same time, the P5 mimic display, the signal line display will update. The symbol for the earth switch will be changed from the open gap to the solid line connected to the ground symbol, providing the intermediate visual confirmation that the bay is earth. Through the object block matrix, the relay uses the digital input 6 says signal to activate interlocking logic. If the earth switch is on, the relay will block any command to close the circuit breaker on Q0. This prevents the deaf earth fault, where you might accidentally energize the circuit that is still connected to the ground. So when you see K01 1Q8 says, the relay is telling you that the bay is safe for maintenance state. Always remember that check your physical locks and tags before beginning the work. Thinking of the status like parking brake on a car. When the parking brake is on, the dashboard car lights turns red. More importantly, at the same modern cars, the computer won't let you shift into drive until your brake is released. In our training stand, the relay won't let you drive, close the circuit brake while the parking brake ground connection is still engaged. The signal digital input 7 K01 lahküüti 1Q1 väljas refers to the digital monitoring of the specific switch device state. For example, digital input 7, this is the 7th physical digital input channel on the P5 relay F1. In the training stand hardware configuration, this input is located on the card C on the I/O module. K01, this identifies bay 1 of the training system. Disconnector 1Q1, this is the disconnector or isolator of mechanical switch used to provide visible isolation gap for safety during maintenance. 1Q1 is the unique identifier for the disconnector and the bay 1. Off or open, this indicates that the disconnector is open position, meaning the electrical circuit is physically separated. Think of this signal like the door open sensor on the safety. Digital input 7 is the specific wire reaching the computer. K01 is specific safe you're looking at, and the 1Q1 is the heavy bolt inside. When the status is off, the computer confirms that bolt is retracted. We already covered that it looks like when your safety ground is active. Now let's look at the primary power path. If you see the status K1 lock activity 1Q1 says, you are looking at the confirmation that your main disconnector is closed. This is a vital step for preparation your bay for service. Let's look at the wiring behind the message. Let's break down the terminology based on the project. K01 identifies compartment bay 1 of the stand. Lock activity, this is a disconnector or isolator, identified in the schemes as LL. 1Q1, this is a specific object ID for the switch. In the standard diagrams, Q1 is disconnector and the 1 confirms that it's first bay. Says, this means on or closed. It tells the system that the physical isolation gap has been closed and the circuit is ready to conduct power. Thinking of the disconnector like the bridge on a train tracks. When the status says the bridge is down, the track is now continuous and the train, once the main signal, the circuit breaker, is turned to green. If the bridge isn't confirmed as on, the signal stays red to prevent the train from falling into the gap. To understand how the P5 interacts with the world, we need to look at the digital inputs and outputs. If the analog inputs are for the relay to understand the measurements, the digital inputs are eyes and hands. They allow the relay to status the switches and physically operate the circuit breakers. Let's break down how they work using specification. Digital inputs are used to acquire data from fields such as position and circuit breakers or commands. These are required in the external control voltage, either AC or DC, to activate. There are two main types: isolated independent inputs, which have their own wiring for total separation, and common connection points inputs, where the multiple signals share the signal return path to save on cabling. Technically, they are highly configurable. You can set the nominal voltage from 24 DC up to 230 V AC and adjust the bounce filter to prevent chatter from making the relay think a switch is bouncing. You can even set activation delay up to 60 seconds if you need to wait for signal to stabilize. Digital outputs are the relay's way to thinking actions. They are mechanical contacts that close or open to trip a breaker. Sounds like alarm or signal on PLC. The P5s uses different types of contacts, normally open, NO, for most control tasks, and the changeover or CO contacts for complex signals. Critical features in the P5 model is the high speed, high breakout. These specific digital outputs can close in less than 1 milliseconds, which is vital for clearing dangerous faults like arc flash before they cause major damage. Every relay also includes a dedicated watchdog (VD) output. This is health signal that stays active as long as the relay internal safety is the best. The P5 has also 20 virtual inputs of VE and 20 virtual outputs VO. These live entirely in the software, allowing you to build complex logic without extra wires. Everything is tied together with the matrix using the output matrix. You decide which starts or trip signal from protection function physically activates which output. You can also choose the latch on output. This means even if the fault disappears, the output stays active, the alarm keeps ringing or the breaker locks until the operator manually resets it. Think of digital EO like a nervous system on the security guard. The digital inputs are the guard eyes and ears, telling them the door is open or if the panic button is pressed. The digital outputs are the guard hands, allowing them physically to turn key or lock a gate. The matrix is the guard's brain, which decides if it sees fire, then it must do alarm. When you are setting up a P5 relay, one of the most important steps for clarity and safety is correctly naming your digital inputs. If you leave them with their factory settings, the operator might only see D1 or D2 during the fault, which doesn't tell them what has actually happened. Let's look at how those names are structured and how they are used in our training stand. In the system, every digital input has two distinct naming fields. First there is label. This is the short identifier limited to the maximum of 10 characters, specifically designed to fit on the relay local LCD screen. Second, there is description. This can be up to 31 characters and provides a more detailed explanation for the user working with the brand software. By default, the relay uses generic numbering system. Label starts as D1 through DX, and descriptions are simply digital inputs 1. However, you can completely customize those names in the names for digital inputs. This allows you to tailor the relay to your specific bay configuration. To see this is practice, let's look at their P stand. Here the digital inputs have been given highly specific names to monitor the states of the primary equipment in the bay K01. Digital 1, the name K01 võimsuslüliti 1Q0 väljas, means that circuit breaker is open. Digital input 2 is K01 võimsuslüliti 1Q0 says circuit breaker is closed. Digital input 3 and 4 are used to disconnect LL. Digital input 5 and 6 are assigned to the earth switch ML. Because they are named this way, the relay can animate the mimic display correctly, showing you exactly which switch is on or off. When you change those names, remember that they are tied to the physical hardware slots, typically slot B, C, D or E. It is also important to note that you have the specific inputs like 12, 14 digital modules, digital 1, which can be used for motor speed counting, the names on configuration for that inputs. We already seen how the P5 sees the world. Now let's look at the digital outputs, the physical hands that operates your switchgear. Just like inputs, giving those outputs really clear, accurate names is essential for safety operations. Now we break down how to name them and see the specific examples. In the software, every digital output has 2 naming fields. First, there's a label. This is short identifier limited to 10 characters, which is what you will actually see on the relay small local LCD screen. Secondary, this is description. This can be up to 32 characters long, and it's used for detailed documentation. By default, these are simply named digital 01, but for relay system, this is not enough. The names you assigned are tied to specific hardware slots. Every P5 has standard output, slot B, including digital 01 and 2 and 3 for circuit breaker controls, plus dedicated watchdog VD signal. Depending on the model, you might also have optional boards, slot C, D or E, for extra signal or arc flash stripping. Let's look at how the outputs are named for bay 01. Digital output 1B is named K01 võimsuslüliti 1Q0 sisse, telling us it's closed in the bay 1 circuit breaker. Digital output 2B is K10 võimsuslüliti 1Q0 välja, meaning it opens the breaker. ADB is labeled feeder terminal rike, indicating a relay failure or watchdog alarm. Moving to slot C, digital output 1C is named K01 lahklüliti 1Q1 sisse for the disconnector, and the digital output 3C is for maanduslüliti 1Q8 sisse for the earth switch. You customize those names under the control menu on the names for output relays view. Keep in mind that this is an editable parameter, meaning you will need to correct passwords and access rights. This ensures that once the system is commissioned, the control label remaining consistent and reliable.